Hello, welcome to the workshop. In this workshop, today we are going to use two switches to latch the circuit on and off, and then we are going to use also a single switch that we use to latch the circuit on and off. As you can see, this is just the circuit diagrams of the transistor latching circuit. This is the theory aspect. From here, we are going to deal with the practical aspect, where you will see the physical component mounted on a board and see how actually we will use this to demonstrate practically the theory circuit that you are now viewing. Now, since we have 1, 2, 3 switches in this diagram, we are using these two switches together in order to switch on and off this circuit, or to latch the transistors on and off. And we are going to use this single circuit in order to latch those transistors on and off. But first, let's come to the two switches here that we are going to use to latch this circuit on and off. Now, how to connect a switch to a transistor circuit in order to latch them on and off. There are 3 ways to connect them so that you will be able to latch them on and off. One way is exactly what you are seeing. You can see here the pin of the switch is connected to the base of the transistor here, and the other pin is connected to the negative. Here also is the same thing. That is one way to connect a switch to the circuit or transistor in this circuit to actually latch that particular transistor. The other way is that we connect one lead. We connect one lead of the switch to the base of the transistor and the other lead to the positive terminal of the circuit, so that you will now close the circuit and a voltage will move to the base. But in this case, you are taking the voltage out of the transistor so that the transistor will have no base current here, and then it will switch off. But in this case, where you will connect one lead of the switch to the base and the other lead to the positive terminal, voltage will flow from the terminal into the base, thereby causing the voltage to flow into the transistor through the base, and it will switch on the transistor. The same way here. The other way here is, one, you should connect one of the switches this way, and then you will also connect the same switch here, another switch here, where you will connect one lead of the switch to this point, and then the other lead of the switch to the positive terminal, so that you will press the button here in order to input a voltage, so that this transistor will switch on and the voltage will be moving. For you to switch off this circuit or the transistor, then you need to use this key here so that it will exactly short the voltage to ground and it will go off. But here we are using these two keys. All what you can see is just to actually cause this base current moving into the transistor to be shorting to ground. The moment you close this pin, the voltage that is moving here will be shorting to ground, thereby stopping or switching off the transistor. That is how we will connect two switches on a circuit to latch that circuit or to latch the transistor on and off. And now we comes to the number one switch. This switch is just a single switch that we will be using to switch on the circuit on and off. As you can see here, we have the circuit diagrams of the switch here. We have three transistors, 1, 2, 3, a capacitor, and then we have the switch. As you can see, the use of this transistor here is just there to increase the voltage into this particular point of the circuit so that there will be enough circuit voltage to move through this transistor in order to charge the capacitor. Why we place this resistor here is that this lead is also serving as a resistor. It doesn't allow a lot of current or enough voltage to pass through here in order to charge the capacitor. So we use this resistor to bypass the voltage so that there will be enough voltage that we will be using to charge the capacitor here. Now we are using this 10K ohm resistor because now we pass enough voltage, more than enough that we needed to charge the capacitor. Because if the voltage is too high, the capacitor is going to charge without discharging. You know, when you connect a capacitor parallel to the when you connect a resistor parallel to the capacitor is going to discharge through the resistor here. As you can see, if the voltage is too high, as the resistor is discharging this capacitor, we find out that it will not completely discharge the capacitor because the voltage here is too high. As it is discharging the capacitor, it is still charging. So because of the high voltage here, we give it 10K so that it will actually pass the maximum or the actual voltage that is required to charge the capacitor. So that in that case, when it is time for the resistor here to discharge this capacitor, it will be able to discharge the capacitor completely. That is the work of the 47,000 ohms. Now we have this capacitor here. What is the use of this capacitor? The capacitor here is there to charge so that its energies that is stored will be used to switch on this transistor. And also, it is also used to shorten the voltage of the base here also to ground. You know, when a capacitor is charged, it stores energy, and its energy is going to use to charge this transistor. Also, if you can see, when a capacitor is fully discharged, it is acted like a short circuit here. No resistance is going to be here. Since the capacitor is now discharged completely, as you close this key, the voltage is going to move back to this point. But what you will understand here is this: when the transistor is off, this transistor T1 is off, there is a voltage here, and this voltage is going to move through this point into this 10,000 resistor, and then some will travel into here, but since it is enough, some will travel into through this resistor, and then some will travel this way, thereby charging this capacitor. As the capacitor is charging, the resistance here is increased, so it stores energy as well. Now when you close this key, the energy stored in the capacitor will now move from this point, come down this way, and then switch on this transistor T1 here. Now when transistor T1 is being switched on, the voltage that is here, that is coming here to charge this voltage, this capacitor, the moment this transistor is switched on, all the voltage is now moving from the collector to the emitter part, to the emitter pin of this transistor to ground. No, there is not going to be any voltage moving in this way, because all the voltage is now moving in this direction here. So there will be no voltage here since you have closed this pin. Now when you open this key here, there is not going to be any voltage moving this way. Voltage is still moving this way. So now since you could open this key, the capacitor, the resistor here is causing this capacitor to discharge, meaning the capacitor is going to discharge through the resistor here. So now since this has completely discharged, there is not going to be any resistance here. This is going to act as a short circuit path. So the moment you switch on this button, close this button, the base voltage of this transistor is going to travel from this point to this point, so that there will be no voltage here, and this switch will go off. There is something you need to know here. In case this capacitor is charged and then you press this button or you close this switch and then you still hold on the switch. Now let's say I close this switch, I still hold on the switch. The voltage or the energy of this capacitor will move through here into here, and this thing will switch on, still holding on this pin here. Now when you hold on the pin and then the energy come and switch this transistor on, all the voltage is now moving, no voltage here. But still, as you hold the key to this point, as you close the key and then you still hold the button, voltage will still move this point, charging the capacitor. So it does not allow the capacitor to be discharged, because since the voltage is now moving in this direction, this transistor is now switched on, voltage is moving this way, voltage is moving this way, and then since you close this, voltage is still moving this way. So it does not allow the capacitor to discharge unless you release this key. The moment you release this key, no voltage will now go this way, and then there's no voltage going this way. So that will allow the capacitor to discharge fully. Now as you close this key, the base voltage here is moving through this point into this capacitor and to ground. But if you still hold the switches here, what will happen? You know that this transistor is already off. So there is voltage moving in this direction to this point, but the voltage that is moving is very small. Some is going this way, some is going this way, and still you hold on this, it will still move this way, but it is not enough to switch on this transistor because the energy here, the voltage that is coming here is too small unless the capacitor is being charged before it will create a higher voltage, sufficient voltage that will charge this, that will switch on this transistor. But since this is pressed when the transistor is off, you know that when the transistor is off, the voltage is now moving this way in order to charge this capacitor. But here is closed. So some is going this way, some is coming this way, and then some is coming this way. So it won't be able to actually charge this capacitor at all. Unless when you released it, when you release the gain, the voltage that was now coming here will add up to this voltage here, and then it will now be enough to charge the capacitor. And when the capacitor is charged, you will now be able to close this pin in order to switch on this transistor. Now what you need to understand here, we are going to do that to demonstrate that when we come to the practical aspect of the circuit. Now you must charge the capacitor in order to latch the transistor on, and then you must also able to discharge the capacitor in order to latch the transistor off. Remember, you must charge the capacitor in order to latch the transistor on, and also the capacitor must be discharged so that the transistor will be able to switch off. Now let's deal with the practical aspect of what we have explained in the theory part of the diagram. Now as you can see, this is actually the practical aspect. You are seeing now the physical component where we have the lead here, the two lead, and then we have two capacitor. We have, two resistor here, and then we also have another resistor. This is 1K resistor, and this is 10K resistor. We have the lead and the transistor. Now we are going to connect one of the switch here to shorten the base current here to ground, or the base voltage to ground, and then we are going to connect one button here. This will be using it to actually input a voltage to the transistor so that the transistor will be switched on. Now let's see how we are going to do it. Now we have something like this. is how to connect the one circuit from the positive terminal to the base of the transistor. And then another switch is connected here. One switch is being connected here. From the base also, and then we connect it to the negative part. Now, as you can see, we have connected the two switches. We are going to use this switch to latch those transistors on and off. One lead of the switch is connected to the positive terminal here, and then we connect it to the base of this transistor, and then we have the other switch where the one lead is connected to the base of the same transistor, and then we connect it to the negative terminal of the circuit. Now, as we power this circuit, you are going to see that one of these lead is going to switch on automatically, and then we will now use this button to latch the transistor alternately off and on. So let's see what will happen. Now the transistor is switched on. This transistor here is actually switched on. So what we will do, we will now use the button to switch or to latch both transistors on and off alternately. Now let's see what will happen. See, the transistor goes off and the other one is switched on. This is what we will do. This is what we will do. So that is how we are going to do in order to use two buttons to switch the circuit on and off. Now we are coming to build a single switch where the capacitor is involved. The capacitor is there to charge charge so that you will be able to give the transistor a switching voltage or a latching voltage, and then you will also discharge the capacitor, and the capacitor will just shorten the base voltage to ground. Let's see what we will do here. Now this is a capacitor which is actually 220 microfarad, 6.3 volt. Now we connect this to the negative terminal here. Now you can remember that I said earlier in the theory aspect of this circuit that the capacitor needs to be charged in order to latch on a transistor in this circuit, and it must be discharged before you can latch off the transistor. Now, since the capacitor is not charged, you will not be able to latch this transistor except the capacitor is latched. So we will connect this lead to the positive part of the circuit, to the positive terminal of the circuit, so that when it will be charged, that we use the charge energy to switch on this transistor here. So now let's charge it. So the capacitor is already charged, so we are going to use it to actually switch on this transistor. See, that is how the capacitor is going to work in the circuit. But now the capacitor is still charging, so it does not actually switch off or latch this transistor off except you fully discharge it. Now before you can discharge the capacitor, you have to connect both lead together to short circuit it. So now we'll use this wire to join the two lead of the capacitor so that it will be discharged. Now we have connected the two lead of the capacitor. Now you see it is going to discharge here. So now you latch off the circuit or this transistor. Now you cannot actually latch it on, switch on this capacitor, this transistor, because the capacitor is not charged. If you want to switch on this transistor using this capacitor, the capacitor must be charged. Now let's charge the capacitor. Now the capacitor is charged completely. We are now using the energy here in order to switch on this transistor. Now let's see. We want to switch it off. It doesn't switch off because the capacitor is still charged. Let's discharge it and see. We discharge the capacitor using this wire to connect the two lead of the capacitor so that the capacitor is now fully discharged. So let's switch off this transistor. The transistor is being switched off, but it cannot go off because the capacitor is discharged. Now we charge it. It is still charged. Now we switch on this way. But if the capacitor is discharged, you can use both parts to charge, to switch it on and off. You can use this path and this path. You can use it like this because it is actually charged. And also if you discharge it, you can use it this way also to operate it. But here we are going to use a single transistor to switch the circuit on and off. For instance, the capacitor is discharged, so it switch off. So it cannot switch on again except it is being charged, except the capacitor is being charged. See, so that is how we are going to use a single switch system in order to latch the circuit on and off. Now let's see how we are going to do the connections. Now we dismantle the host key here. This is actually the capacitor being placed in this direction here. Connect it to the base here. We are using the 560 ohm resistor here. Now switch off the circuit. This is the 10 kilo ohms of resistor. And then we also have this connected to the base here. Then we have to connect the key here. Then we connect it here as well. So we connect this here. Connect that way. Now we are connecting the switch. Here. Now, as you can see the connection, we have now done the circuit connection of how to use a single switch to latch the transistor on and off. Now let's power the circuit. Now we power the circuit. One lead is on and the other lead is off. Now let's try to use this single button to switch on this circuit on and off. See. Now what you need to understand here is this. Now as you are seeing, the lead is actually on. So therefore the voltage that will come in this direction to charge the capacitor, there is no more voltage coming to charge this capacitor. It is actually moving through this resistor to ground. Also, now that there is no voltage to charge this capacitor, this resistor is discharging this capacitor. So now, since the capacitor has been discharged, what will you think will happen? When you press this key, the voltage that is to the base of this transistor will now move through the key to the positive terminal of the capacitor, and then it will pass through the capacitor to the ground. So that will actually causing this lead to switch off. Now, since this transistor is off, the voltage is no longer moving in this direction, passing through the resistance, the transistor, because the transistor is being switched off. So what will happen? The voltage here is now moving in this direction into this point through this 10K resistor into the capacitor, thereby charging the capacitor. Now the capacitor is being charged, so we are going to release what the energy stored in the capacitor to actually latch on this transistor. Now let's press the button, you see. But in case we still hold the button, now we have something like this. Now the capacitor has been discharged, you see. So the capacitor has been discharged on and off, on and off, on and off, on, off, on, off. So that is how we will use a single switch in order to latch the transistor latching circuit on and off. So watch the demonstrations of switching off this transistor as I also use the single switch. Off, on, 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 off. So that is how to actually connect your switches so that it will be able to switch the transistor on and off. Thank you very much for watching this video. I think we have done with latching. The next video that we are going to produce in the workshop is a multi-vibrator circuit where we will be using 2 lead, 3 lead, 4, 5, 6 lead. Also, it is just the same circuit like this, but in this case you are not going to use a lead or a switch to manually switch on both transistor on and off. it will be automatic, and we will connect a capacitor in order to make it automatic to do that particular job. You will switch it on and then it will switch off, but it is going to be automatic. It is not going to be manually operated. That is a multivibrator. You will see both light or lead are switching on and off alternately. So thank you very much for watching the video. Look for the next video that we actually see how to build a multivibrator circuit. Thank you very much.